Due to time constraints, we will now kick off with the second session. I would like to thank Dr. Elizabeth Vega and now Dr. Telma Castro, a researcher from the Science and Climate Change Study Center, who will be moderating the next session.
Gracias, Ramiro.
Thank you, Ramiro.
Muy buenos días a todos.
Good morning, everyone.
Ha sido sumamente interesante
It's been a very interesting meeting, listening to presentations this morning, and I can only expect that the next thing, the things to come will be equally good. So I think we are in the face of a very important opportunity when talking about tropospheric ozone for those of us working and living in a city like Mexico City. I want to thank organizers for their invitation to be a moderator. And here we're going to have 3 speakers in the second session. And since we are falling a little bit behind the schedule, I will then start with Dr. Lisa Emerson. She is a professor on environmental science from the Environment Department from the York University in the UK. She has over 20 years of experience in the field of modeling soil systems to evaluate risk of impacts in atmosphere pollution and climate change. She plays a key role in research in Europe by developing methodologies for replacement, methods of risk evaluation, flow states, and modernization tools of cultivation for use under the framework of the UNCD on long-term transborder pollution. She has recently been analyzing effects of GHGs and atmospheric pollutants coming from agriculture and evaluating variability and the applicability of satellite imaging to identify tropospheric pollutants and to attribute emission sources by collaborating with colleagues in identification of satellite data and inverse modeling of atmosphere chemistry. She's a part of scientific panel for the Clean Air Coalition and the Leaders Forum of the AGIM, where she advises on the benefits of action against climate pollutants, short-duration climate pollutants in relation to productivity and ecosystems. So she will be talking about a very interesting subject today, which is impacts on ecosystems. Dr. Lisa Emerson, would you please take the floor? The floor is yours, doctor. Dr. Lisa Emerson, you have 15 minutes and 3 minutes before the end of those 15 minutes. I will be alerting you that you have 3 minutes left. Dr. Lisa, over to you. The floor is yours.
Hello. Thank you very much. I hope you can hear me. I'm assuming you can. Yes, okay.
We can hear you loud and clear, doctor.
It's okay that I do this in English as well, because my Spanish is not very good. So I hope that's good for everybody as well. So thanks ever so much for letting me come and give a talk about ozone impacts on ecosystems. I think I've got around about 15 minutes to try and cover this, so I'll try and keep to time. And if I could have the next slide. Great, thank you. So I just wanted to first off point out this kind of rise of ozone as a super pollutant. Here's a caricature of what ozone looks like according to the UN Climate and Clean Air Coalition to try and raise awareness of the importance of tropospheric ozone. Super pollutants are really important to try to control. They have both radiative forcing effects as well as being air pollutants, and they're short-lived. So if we tackle them, we can get some benefits in the near term. And generally speaking, I would say that ozone is considered in terms of its human health impacts, in terms of it being a pollutant. But I want to try and talk about some of the ecosystem impacts that ozone causes. So if I have the next slide. So we know that ozone does cause damage to ecosystems. But I wanted to just give a flavour of how we get that information, where that knowledge comes from. If I can get the next slide. So we have a reasonable idea of ozone concentrations around the globe. That map gives you shows you measured ozone concentrations, which come from the TOR database. That's the Tropospheric Ozone Assessment Report database, which stretches back to 1970s. But you get an idea that we have a lot of information in North America, in Europe, and some more emerging in Asia at the moment. But there are large areas where we don't really know exactly what the ozone concentrations are. And then coupled with that, we need to try and understand what the ozone impacts to ecosystems might be. And I've just put two images of the experimental apparatus that are used to try and assess that. We've got open top chambers on the top, and then we've got free air concentration enrichment sites on the bottom. Basically, these will fumigate plants over the course of a growing season with a known level of ozone concentration, and then try to understand what the impact might be on, for example, crop yield losses and forest biomass losses. If you run through the next slides, you'll just get an idea of where the kind of level of experimental detail is coming from around the world. So back in the 1980s, we had the North American crop loss assessment that looked at 6 sites, 6 crops over 7 years. So we have a large amount of experimental data coming from that program. If you hit the next slide, then we also in the 1990s had the European Open Top Chamber program, which focused largely on wheat. Next slide. Sorry, there's a few buttons to press here. So in Asia, there's also a huge amount of data that's coming out of Asia, experimental data since the 2000s. No coordinated programs running there, but we've had lots of studies performed on crops and forests. And the next slide, just to flag the fact that we really don't know very much about ecosystem impacts on crops or forests in Africa. And the next slide. And this is just to show that the yellow colours give an idea of where we have FACE sites, FACE experiments, which deal with crops. And we also have FACE experiments, which deal with forest trees as well. Just gives you an indication that the data exists, but for some parts of the world, it's quite limited. Next slide. So this is just to give an idea of the types of damage that we see. We tend to focus on crop yields, but the list here shows that there's a large number of other effects that ozone causes to crops. And if you hit the next slide, the graph on the right, you'll see some of the yield losses. Hit the next slide. Sorry, can you hit, that's it. You get an idea of the size of yield losses. So these are yield losses compared with a baseline of around about 26 ppb of ozone, and you're increasing the ozone concentrations anywhere between 30 and 50 ppb. And we're seeing quite substantial yield losses in some sensitive species such as bean and wheat, anywhere between 10 and 20% from this experimental data. Next slide. Similar kind of situation for forest. Again, pulling together all of this experimental data into meta-analyses, you can get some idea of the range of different effects, physiological effects, carbon allocation, competitive interactions, and so on. Although we tend to focus on impacts such as growth and biomass when we talk about ozone effects on ecosystems. So really, this is just to give an indication that there are a whole load of other effects that we see ozone causing to ecosystems. Next slide. And just to also show that there's evidence of visible injury close to where a lot of people on this call are going to be, a national park in Mexico from the 1990s. And that visible injury was due to photooxidant injury, of which ozone would play an important part. Next slide. So we have a lot of experimental data. We need to work out how to use that experimental data to estimate ozone risk to ecosystems. And part of that is working out what is the best metric to use. How do we best characterize ozone concentrations or ozone exposure? Next slide. So there are bunch of different metrics that have been developed over the past 2 to 3 decades. I'll just try and quickly run through these. Here you can see the black jagged line gives you the hourly ozone concentration over the course of a year. If you hit the next slide, you'll see that we can characterize that. Can you hit the button, the next slide button? You can characterize that as an annual mean. That's not terribly useful if we're talking about vegetation where it's mostly physiologically active during the day. So if you hit the next slide, then you can see the line for the annual daylight mean. And then we need to consider that vegetation is obviously normally has a growing season when it's physiologically active. So if you hit the next slide, then you can see the value, which tends to be used quite a lot, M7 and M12 metrics, which give you a growing season daylight mean. And then more recently, if you hit the next slide, you see that we can also start to accumulate metrics, which such as AOT40, which identify the higher concentrations of growing season, the higher concentrations of ozone that are experienced during the growing season. And the next slide will give you an indication of this metric that I've identified in red, phytotoxic ozone dose over a threshold. Here, rather than looking at the ozone concentration, we are looking at the stomatal ozone uptake because we understand that that is a better descriptor of actual damage than concentration-based metrics. So if you hit the next slide, we can look at these different metrics and we get similar statistical robustness when we use these metrics to develop dose-response relationships in terms of R-squared values. But when we apply these different metrics globally or regionally, they might give us different estimates of yield given the ozone concentration profile in particular regions. If you hit the next slide. So we use those metrics, we have the experimental data, we can produce dose-response relationships, which is shown here. And we have evidence now that this POD-Y metric, which looks at the stomatal ozone flux, is actually a superior metric to the concentration-based metrics such as AOT40 or M7. And that's seen here where the POD-Y metric dose-response relationship on the right is showing a better statistical relationship between the POD6 metric and relative grain yield in this case, with data taken for wheat from experiments across the world, Europe, USA, and India. And that's because this POD-Y metric accounts for environmental conditions, hot, dry conditions when you have high ozone concentrations that will also lead to closure of stomata. So you decouple ozone concentrations from ozone damage. So we need to understand that stomatal ozone flux to really get better estimates of ozone damage to ecosystems. Next slide. And then we can use that kind of dose-response relationship in terms of air quality management. If we know what our emissions are, leading to ozone concentrations through atmospheric chemistry transport models, and if we can characterize those ozone concentrations in relation to these metrics and use a dose-response relationship, then we can either identify areas where we might have exceedance of a critical level or air quality guideline, or we can actually work out what the agricultural impacts might be if we use those relationships with agricultural statistic data for a particular region. And if we have that kind of information, then we can feed back to work out where we can most effectively target emission reductions. Next slide. And just to give an indication as well that if we look regionally, these stomatal flux-based metrics do seem to perform better. Two different maps here, one AOT40, one POD3. The black dots on those maps give you an indication of where biomonitoring experiments showed that there was some sort of damage caused by ozone. The dark green gives, or the dark and the light green give you an indication of where those different metrics would suggest damage was being experienced. And so you can see that with the POD3 metric, we have the POD3 metric giving you an indication of damage in those areas where we actually saw damage, which we don't see with the AOT40 metric. So it seems to be a better predictor of geographical distribution of ozone damage. Next slide. So we kind of feel like we've got a good understanding of metrics that are good at being able to describe where ozone risk is occurring. Yep, next slide is good. And then we can ask the question, well, what are the trends globally in terms of the variability in those metrics and whether ozone exposure is becoming more of a problem, becoming less of a problem, or staying about the same. So we did a study, again, as part of the TOR, Tropospheric Ozone Assessment Report, where we looked at ozone concentrations globally between 2005 and 2021, and looked at different metrics and different species, so wheat, rice, soybean, beech, and forests, and tried to understand whether the ozone exposures were increasing, decreasing, or staying the same. So you've got two different graphs here, one for M12 and one for Pod Y. If we take different regions, you can see we've got NAM, stands for the North American region. The brackets give you an idea of the number of sites where we had ozone measurements for. And essentially, you can see both those metrics are suggesting that actually around about 40 to 50% of those sites are seeing a decreasing trend. So that ozone exposure is improving, is reducing across North America. By contrast, if you look at Asia, signified by the AS, then you can see that somewhere between 20 to 25% of those sites is actually seeing an increasing trend in more exposure, which is potentially leading to more damage. Next slide.
Lisa, 3 minutes to finish, please.
Okay, yeah, that should be good. And then just to sort of a caveat with this work is shown here in terms of the spatial distribution of those sites. We have quite good spatial distribution across North America, reasonable across Europe, but some of the Asian sites which showed an increasing trend just located in one region here, shown as in South Korea. Next slide. And then just a couple of other things to mention. We often get asked how ozone impacts compare with other stresses. Go to the next slide. And we did a study which looked at how ozone stress compared with other stresses which impact agriculture. Here we worked out a yield constraint score. So we worked out how these different stresses were impacting yield in bins of 0 to 5%, 5 to 10%, 10 to 15% yield reductions. And we found that ozone is actually similar to nutrient and heat stress. It's sometimes higher than aridity stress, but it is lower than pests and diseases stress. And we also found that those areas where you have high ozone-induced yield losses also tend to see high losses from these other abiotic and biotic stresses. Next slide. And we know that ozone interacts with other stresses, especially temperature, CO2 concentrations, precipitation, and so on. So we're starting to consider that we need a different approach to ozone risk assessment. Next slide. And we've started to try and develop different ozone risk assessment methods. Next slide. So rather than taking the traditional approach, which I've described in this talk, where we might have experimental data, we produce a dose response function, and we work out what the relative yield loss due to ozone uptake might be. Next slide. We now insert some sort of process-based crop model that allows us to estimate absolute yield losses and also the effect of climate variable stress. So we can look at ozone and climate change together. Next slide. A number of models have been developed. This is just a description of the dose crop model, which we've developed. We've essentially inserted a crop model within our dose dry deposition model. Next slide. And we've applied these different models just to show how they work. This is data from an open-top chamber experiment near Madrid. We ran 3 different crop models, and you can see different treatments in the graph here. What this is showing you is that the 3 different models in coloured bars are giving you a pretty good estimate compared to the observations in the grey bar of the impact of ozone, the impact of drought, and then the impact of drought and ozone in combination together. So we're producing models that can look at these multiple stresses together. Next slide. And then finally, just to think about some future research, there's been a tendency, I think, in terms of ozone and ecosystem impacts to look just at ozone alone and be thinking just about air pollution challenges. But I think there's scope to be looking at a wider, broader set of environmental challenges which ozone has an impact on. And I've just tried to indicate some of those here. We can think about nature-based solutions and how ozone is impacting carbon sequestration within forests. And then also I've talked about things like human health and well-being, where we're concerned with ozone's impact on crop supply, which will influence food security. So thinking more about these different entry points for ozone research would be very useful. And I think that's it. Thank you very much.
Thank you very much, Lisa. Muchas gracias, Lisa. Muy
Thank you,
interesante
Lisa.
escucharla.
That was a really
Ahora
interesting
pasamos a la
presentation.
otra charla.
Now let's go to the next presentation.
Por,
It will be delivered
la
by
doctora Pallavi
Dr.
Pant. No sé si
Pallavi
pronuncié
Pant.
bien,
I don't know
sí.
if
La doctora Pallavi
I
es una
pronounce it well.
científica
Dr.
especializada en
Pallavi
salud
is a
ambiental, cuyo trabajo se
specialized
centra en la
scientist
contaminación del
in
aire y la
is
salud
studying
en
air
países de
pollution
ingresos
and
bajos y
health
medios.
in low
Como
income and
directora de las
intermediate income
iniciativas globales
countries.
de
As a part of the global
Institute,
initiative of the Health
lidera
Effect
los
Institute,
esfuerzos
she
para la
leads
síntesis y generación de
processes
evidencia,
for
el
synthesis and
fortalecimiento de
generation of
capacidades y la
evidence,
comunicación
capacity
científica
building,
en
and
torno a la calidad
scientific
del aire y la
development in
salud.
terms of
Su
air
trabajo
quality
tiene
and
un
health.
de puentes entre la ciencia y las
Her
políticas
work
públicas,
builds bridges,
ayudando a conectar la
bridges
ciencia
between
rigurosa con las
science
ambiciones
and
poblares
policy,
más limpias.
connecting
Forma parte del
and
Consejo Editorial
science
Laws
with better
Global
policies. She is a
Public
part
Health
of the board
y
of the
preside
House
el
Public
Consejo de
Health, and she
Administración de
chairs
Open
the
ACOM
Council of
y es
Open
asesora de
ECOM.
iniciativas
She's
internacionales
also
a través de la
advising
Organización
international
Mundial de la
initiatives
Salud
through the
y la
World Health
Coalición de
Organization
Clima y Aire
and the
Limpio.
Climate
La doctora Pant
Coalition and
tiene un
Air Clean
doctorado en
Air.
salud ambiental por
Dr.
la
Pan
Universidad de Brigham
has a
en Reino
PhD
Unido
of
y una maestría en
environmental
ciencias ambientales por
health
Harvard
and a
School of
master's in
Health
environmental
de
science
Delhi
from the
en la India.
School of
Ella nos va a
Tehri in
hablar sobre
India. She will
impactos
be
en
talking
salud.
about health impacts
Muchísimas
of
gracias,
exposure to ozone.
doctora
Thank you very much. Dr. Pallavi, over to you.
Muchas
The floor is
gracias,
yours.
Salma. Sí.
Okay.
Hola. Buenos días. I will speak in English for most of my presentation, but I'm really enjoying practicing some of my Spanish. So thank you very much for this opportunity and for this excellent seminar. I've already been learning so much. And I think a lot of people have already spoken or referenced about how exposure to ozone also impacts health. So I'm going to try to take you really quickly through what we do know about the health effects of ozone and what that means for people's health around the world. Next slide, please. For those of you who may not know, the Health Effects Institute, we are a nonprofit organization primarily working on topics related to air pollution and health. We produce an annual report called State of Global Air. I will be borrowing a lot of messages and data from there. But we also fund research on topics around how air pollution can impact health. Next slide, please. So I think we've heard already from many of the speakers so far that ozone exposure is a problem in most parts of the world. And I'm really glad, especially to be going after Lisa and Mark, who've spoken a little bit about the availability of data. But based on the information from ground monitoring stations that we already have, combining that with models, we are now able to estimate what the average exposures to ozone are in all parts of the world. This data is not perfect. We're still missing lots of ground monitoring information. So hopefully we can continue to fill those gaps. But what we have tells us that about half of the entire global population is living in areas where the ozone exposures can exceed even the least stringent targets that the World Health Organization has set, which are based on the health evidence, some of which I will talk about. So this clearly is an issue that really requires a lot of attention. And when we think about pollution, as has also been said by previous speakers, we often start by prioritizing PM 2.5, but we look at some of the health effects and the implication for productivity, we really need to be paying more attention to ozone. Next slide, please. So in terms of a general summary, we know now that each year air pollution is responsible for millions of deaths. The number can go up and down a little bit. You may have heard 7 million deaths or 8 million deaths or 9 million deaths. But the point I really like to emphasize is that it's one too many millions of deaths because of air pollution, and a majority of those are occurring in low and middle income countries. And when we start to compare both the exposures and also the health impacts for air pollution, this includes both PM 2.5, ozone, nitrogen oxides, etc. The rate at which people are exposed to these pollutants and also the rate at which their health is impacted is way higher for some of the low and middle income countries compared to high income countries. Next slide, please. And again, if we broadly look at how air pollution impacts our health, this includes particulate matter, nitrogen dioxides, ozone, black carbon, all of those pollutants. We know now that air pollution really impacts all of our organ systems, all the way from our lungs, which is something we tend to most closely associate with air pollution exposures, but also our heart, our metabolic system, our skin, our brain, and really all the way from pregnancy to late adulthood, we can see the health effects of air pollution in a variety of ways. Next, please. And what it essentially means is each year, 1 out of every 8 deaths that are happening around the world are coming because of air pollution exposures. Next slide. And in that larger scheme of things, so we have about 8 million deaths annually. Of those, about 500,000, close to 500,000, are linked with exposures to ozone. But I want to add 2 points there. One, when we look at these burden numbers, we are really only looking at certain diseases, and we are only looking at long-term effects. So it is likely that the numbers we have for ozone-related health effects are not as accurate, not as complete, because we're not taking into account the full range of health outcomes that we are continuously learning are getting impacted by air pollution. And what I mean by that is short-term exposures, which could be anything from a few hours to a few days, where we are getting exposed to higher levels of ozone. This can happen if there is an ozone episode. This can happen especially during summer season, when many places experience exceedances of ozone. I know this has been an issue in Mexico. This has been an issue in really many parts of the world. This can mean that more people are visiting doctors, more people are getting admitted to the hospitals for respiratory issues, in some cases, extreme asthma exacerbation. So people that may be living with respiratory diseases already requiring more medical attention. And often when we think of the health effects, we stop there, but we really think about what the immediate impacts are, but also think about a child having an asthma exacerbation requiring to go to the doctor or requiring hospitalization, and what that would mean for the parents. They may not be going to work, the child may be missing school. So there's also a whole other layer of impacts that can come from this. But also, we have seen evidence now from studies in many different locations that when children are breathing in ozone or getting exposed to ozone, they can experience a reduction in their lung function. Lung function is a very basic metric that we use to see how healthy a child's lungs are, or even an adult's lungs. And exposure to air pollution generally, but also to ozone specifically, can mean that the lung function is reduced in the long term. So when we are getting exposed to these ozone levels over months and years of our life, this can result in an increased risk for chronic respiratory diseases like COPD, or chronic obstructive pulmonary disorder, which is a disease that cannot be cured. It is a disease that somebody will live with for the rest of their life. And exposure to ozone can not only cause this disease to occur, but also increase the risk of dying because of COPD. Even in Mexico City, I found there has been work trying to understand what the impacts of ozone may be, and in line with what we see for the global literature, increased number of respiratory disease consultations, especially in older adults. But again, I'm mentioning here one more time that when we look at the burden numbers, so the total number of people estimated to have died as a result of exposure to ozone, we're really only looking at very specific outcomes right now because the evidence for some of the other health endpoints has been growing. So hopefully we can expand it in the future. Next slide, please. So for ozone specifically, based on the data from State of Global Air, for 2023, which is the most recent year that we have information for, there were about 470,000 deaths. And this also meant more than 8 million years of healthy life lost. What that means is people that weren't able to go to work, people that weren't able to be productive and engaged and active in their day-to-day life. And another astonishing and really critical data point that I do want to highlight is of these 470,000 deaths, 90% and more were in low and middle income countries. In fact, 1 of every 2 deaths in 2023, which was linked with ozone exposure, was just in India, in one country. And in the last 2 decades, we have seen a really rapid increase in the number of deaths that are linked with exposure to ozone, partly because we have seen increases in levels of ozone. So this is a problem that's becoming larger. And the other point that I want to highlight is often ozone exposures can bring a higher level of risk for older adults. So if you look at this graphic here on the screen, you see 3 colors. Each of them is representing a different pollutant, and yellow is what is representing ozone. So relative to particulate matter, the overall contribution to the air pollution health impacts is lower. But as we go on the x-axis from left to right, on my screen at least, so from close to the axis to away from the axis, we're looking at different age ranges. And if you notice, ozone starts to become really prominent as we get into the older ages, 60 and above, 70 and above is where we see the biggest impacts. Now, if we couple that point with, with our understanding that many countries are seeing aging of populations, and we're seeing increases in levels of ozone, that just lays out for us why it is important to be thinking about how ozone is affecting people's health and also what we should be doing to really address it. Next slide, please. Finally, I think this already came up in terms of questions from people, and yeah, you can hit next and fill the full slide, that's okay. Heat is becoming front and center, an issue that governments are thinking about, that researchers are thinking about, and that people are dealing with every day.
Hola, ¿cómo estás?
We've had heat waves in multiple regions around the world, even within the last few weeks, as you may have seen, or perhaps you've experienced it wherever you're joining from. And there is increasing evidence to show that when we have conditions where there's high heat and high air pollution, and often because we know that ozone production tends to be higher with high temperatures and sunlight, we're seeing more and more evidence coming out that the joint impacts of heat and ozone exposures and heat and air pollution can actually be even more dangerous for people's health. And we have seen this evidence not from 1 or 2 locations, but from hundreds of cities around the world. So again, something to be thinking about from a health perspective on how we create responsive policies. Next slide, please. I think in conclusion, I'm hoping that what we can take away, at least from this short intervention, is that for ozone, we're seeing about 500,000 deaths, give or take, each year as a result of exposure to ozone. And this is only looking at long-term exposure, so there may be more immediate impacts, more strain on the local healthcare systems in the short term when ozone levels are higher. And older adults tend to be particularly vulnerable to these impacts resulting from ozone exposures. But also, we do have an opportunity here to use the data that we have also to better connect data on ozone exposures and some of the health outcome data so that we have a stronger case for why we need action, and we can also use it to decide what action we really should be taking. Next slide, please. I think I will close here by really encouraging all of us to take note of the evidence we have. It is quite robust. It continues to grow. And given that we are experiencing high levels of ozone, increases in levels of ozone in some parts of the world, and also this additional effect or this additional threat of heat combining forces with air pollution, how can we best use all of this evidence to inform policy as it is happening right now? But also to the scientists in the room, how can we fill the data gaps that remain so that our evidence becomes even more robust? Happy to talk more offline, and thank you again for this opportunity.
Muchísimas gracias, doctora Pallavi.
Thank you very much, Dr. Pallavi. Brilliant presentation. It's very interesting because we have cultural insights that are so important. Thank you very much. And yes, you even had a minute to spare, but anyway, thank you very much for sticking to the time. Now, let us move on to the next presentation by Dr. Nahal Morford, Head of Scientific Issues by the Climate Coalition. He is specialist on atmospheric pollution, climate change, with a trajectory focused on reducing climate pollutant, short-life climate pollutant like carbon and methane. He is the head of scientific matters in an international alliance housed by the program of the United Nations. He is participating, linking science, public policy, and international actions to reduce atmospheric pollutants that affect simultaneously the air quality and public health and climate. His professional experience fits perfectly with knowledge on science, environmental sciences, public policies, and environmental law. His main areas of work, we have analyzing strategies to combat emissions of black carbon and methane, as well as the evaluation of the benefits that these reactions can have for climate change, air quality, and public policy. And he will tell us about his scientific findings to reduce tropospheric ozone. So, Dr. Nathan, the floor is yours. You can start your presentation. Thank you very much. Thank you, Doctor, and thank you, everyone. Thank you for this invitation to discuss this subject with you.
For clarity's sake, I'm going to do this presentation in English. And I'm in very good company. It's nice to see a lot of old friends here, and I think there's a good synergy bookending this section with Lisa. Since she's speaking from Old York, and I am speaking to you guys all from Nuevo York, at least for the time being. I'm on my way, moving to the Philippines later this afternoon, but I'm really happy to be able to take the opportunity to speak with you guys today. I know we're well over time, so I'm going to try to shorten up my presentation a bit. To talk about, how the CCAC looks at, how we are a science-based institution ourselves, how that's led us to look and advocate towards addressing tropospheric ozone and what that's meant in practice over the last 15 years, and how hopefully we will continue advancing our work on tropospheric ozone going forward. So, Lisa's already showed off. She's given away the game with our little our super pollutant characters there. You'll see ozone up in the top right corner. Lisa, you don't know this, but I'm working on making some new ozone characters for the launch of the agri-food assessment that you are co-chairing for us, which you did not mention. And I'm going to show some of those off here today. You guys can grade me on whether or not you like our representations of ozone. Next slide, please. So for those of you who don't know, this the CCAC, I'm not going to discuss how we were founded in detail, but we are, as I said, a science-based institution. We were founded on the basis of an integrated assessment, the integrated assessment of black carbon and tropospheric ozone, which asked at the time, which was unfortunately quite a novel question, that was whether or not we could identify a set of specific actions that achieved net benefits for near-term climate and air quality, taking into account all relevant pollutants and emissions and co-emissions from various sources, which of those sources could provide those two specific sets of benefits. And those led us to famously a set of 16 measures back in 2011, and then for the founding of the CCAC, which focused on major sources of methane, black carbon-rich sources of PM 2.5 primarily, and then sources of HFCs. That's a different issue. But focusing on methane, the reason we were able to justify methane within that framework is because of its importance as a precursor for tropospheric ozone. The public health benefits that we calculate for methane mitigation come from the reduction in ozone that comes from it. Obviously, also in terms of temperature impacts and benefits, but back then primarily it was an assessment of how that impacted ozone concentration, formation, and exposure. I should point out, however, in terms of the ozone reductions that we found from the 16 measures in that assessment, about half of the total ozone reduction came from methane measures. The other half came from reductions of co-emitted pollutants from those black carbon-rich sources of PM, so carbon monoxide, for example, or NOx. So we've, since 2011, have been working on tropospheric ozone. Next slide. And advocating for it amongst our partnership. One more click, please. There we go. There's one of our first new characters. You guys tell me if you like. No, stay there. So I won't stay on this slide too long, but I will say, because of that frame and how we were set up in the CCAC, we are a science and policy-based institution that focuses on measures, specific actions that achieve net benefits, both for climate and air quality. That has been really quite effective. There are many people on this call who have helped us in the journey, both advocating that from a science and policy perspective and doing it on the ground from a regulatory perspective or implementation perspective. And it's worked very well over the years, except in one small in the particular instance of tropospheric ozone. As you'll see, I'm not going to explain this flow chart. I mean, it's quite complicated, but the reason I wanted to put it up is that, you start on the left with specific sectors that are emitting complex sets of emissions. The next row or the next column are emissions, and the next column is concentrations. And the problem is that ozone doesn't show up in emissions, as we now all understand from the presentations today. It's a secondary pollutant. So from an advocacy standpoint, because in the CCAC we are a measures-based institution, you have to go 2 steps down the chain to get to concentrations. And when it comes to advocating for action, it's a heck of a lot easier, we've found, to advocate to our communities over the years based on emissions reductions and the health impacts and benefits that come from it. And we usually skip over meaningful conversations about tropospheric ozone and how it can be managed uniquely beyond what we get when we address the specific measures. And because of that, I will admit that's left us with a bit of a blind spot, particularly from an air quality management perspective, because ozone is much more complicated than PM. And while you certainly can have a significant impact on total ozone concentrations by addressing, in particular, methane, from an air quality perspective, you cannot really manage this issue unless you are looking at, NOx and VOCs and the particular regime that you exist in your particular locality. We are shifting that, and I'll talk a little bit about that here in a few slides. So next slide. So I will I'm not gonna dwell on this one, but as I said, we are a science-based institution. We were founded on the first assessment in 2011 and have continued to produce new assessments, particularly regionalized assessments based on that initial framework, evolving and expanding on that initial novel question in 2011. The first regional assessment we produced was actually in Latin America and Caribbean. It was many of the people who have spoken on this call have actually participated in that. Luisa Molina was actually responsible for the progress and opportunities supplement report that was published with the LAC assessment. Next slide. And so, as I said, because of the framing and the nature of how we think about this issue of climate and air pollution, right? We're a measures-based institution. We've followed sort of that measures-based methodology, and that flows through all of our assessments. And it has, as I said, because of the complications with ozone, made it somewhat easier for ozone as a unique problem to get less attention in the CCAC than a lot of the other pollutants, because you can actually address the emission sources of those other pollutants. And ozone has always been a benefit of mitigating those pollutants. The first time we really tried to address this in a meaningful way, to try to put a greater lens on ozone, was actually in 2021 with the global methane assessment. A few of you listening today have heard me talk about this or lament about this in the past. The actual genesis of the global methane assessment was an attempt to go through a multi-model exercise to see if we could develop coefficients that could translate a change in a ton of methane into projections of that impact on ozone formation around the world. We were successful in that analysis, which then was the scientific basis for the development of that global methane assessment. The political momentum that the global methane assessment generated, which led to the launch of the global methane pledge later that year, kind of overwhelmed, I think, that scientific and communication innovation around tropospheric ozone. And I do regret that, because we have been trying to elevate ozone and the public health impacts of it over the years. That was just one example of where I think we made it a really substantive contribution to the policy and scientific community, but it didn't make it into our communications quite as well, or understanding in our community as well as I had hoped it would. Next slide. So yeah, keep one more. Okay. So I won't repeat myself. This is kind of what I was mentioning here before. So this is a major slide from the global methane assessment. Lots of people have seen it. Lots of our policymakers have used it. It's on the Global Methane Pledge website right now. What I fear is that a great many of our policymakers don't recognize is that ozone is responsible for 3 of those columns of impacts. Specifically, in fact, well, it's also responsible for the warming or avoided warming as well, but very specifically on avoided deaths, avoided asthma-related ER visits, and avoided crop losses. Those are all coming from tropospheric ozone, and it's something I think it's on my plate to elevate that knowledge in particular. Next slide. So this is a bit of a theory of change for the Climate and Clean Air Coalition. I'm not going to go through it in detail because it would take me half an hour, but just to say, we've been recognizing the CCAC to be very good at the first 3 of those building blocks, and are progressing on being better at improving implementation readiness and scaling mitigation. But what we've been quite effective at in terms of the science to policy interface is obviously generating the analysis and the evidence, largely through these kinds of integrated assessments and other science and policy related work, drawing from our partnership, their knowledge, integrating that into the evidence base, which is and then supporting policy integration that's helping develop super pollutant plans, management plans in countries, supporting capacity building in countries, supporting specific activities like capacity building around NDCs or methane roadmaps under our methane roadmap action program, and then helping countries institutionalize that kind of integrated climate and clean air perspective and management structure, and we're pivoting into 4 and 5, and that's kind of the space that I live in, and we've been quite good at that, except as where I mentioned that our one blind spot on tropospheric ozone. So I want to now jump to 2 examples of where I think we're getting better on translating the science of ozone to our policymakers and supporting capacity building. So next slide. Good. So the first is the Africa.
Dr. Nahal,
Yeah.
3 minutes for finish.
Yeah, no problem. All right. Anyways, Africa Clean Air Program. It's created by the African Union with the support of the CCAC. It is the foundation for it is an integrated assessment for Africa and sustainable development, which we developed with the African Union and actually quite a few people on this call. Next slide. Through that, the Africa Clean Air Program has developed 5 pillars, which this is still being negotiated, but a 5-pillar roadmap and implementation plan to address air pollution, climate change, and sustainable development within the framework of their existing legal infrastructure and development plans. Next slide. It includes all of the identified measures that again, with the original assessment, we had 16 measures. In Africa, we had 37, a lot more robust and higher resolution analysis. Next slide. And one of the things that we're doing to support scientific development, capacity building in African countries to help to implement the APCAP program, but also to continue generating the scientific basis for action is supporting these a new set of centers of excellence, which again I won't go into detail, but will provide ongoing and systematic support for air quality management and climate mitigation and sustainable development in Africa. Next slide. And these are the locations of them thus far. Next slide. Yeah. The other, I think, really quite exciting thing that we're doing, and it was launched 2 years ago, is the AQMX platform. This is a one-stop shop for tools and guidance on air quality management. It is for air quality managers. It's tuned for every country at every level of development or air quality management experience and knowledge. There's a QR code there that can get you there. Next slide. This is where we're putting all of our information, both that's self-generated and generated by our partnership. Next slide. Sorry. Next slide. Okay. And we're constantly developing guidance on how to support air quality managers to address PM 2.5 and on ozone. We have the first 3 sets of guidance that are out already. That's air quality monitoring, source attribution, and emissions inventories. Stages 4 and 5, so that's health impact assessments and environmental impact assessments, are actually going to launch on Clean Air Day this year, so that's September 7th. So stay tuned for that. But I encourage everybody who's interested in this topic, particularly as Luisa was mentioning in the beginning about needing to have an integrated approach on managing PM and ozone from an air quality perspective. Please take a look at this and participate in the AQMX community, because it's a really exciting place for this work. Next slide. Yep, there we go. Hopefully I made it under time. Thank you very much. Happy to take questions.
Y muchísimas gracias, Dr. Nahal. Un panorama muy
Yes, thank you very
importante
much,
sobre
Dr.
todo
Nathan.
el trabajo
Very
de
important landscape, especially in regards to clean air.
Muchas aristas. Bueno,
That really opens up a lot of spaces. We are well over time. We are way behind in our agenda. There are just a couple of questions to Dr. Emerson. If you could clarify the opposed signal of Korea and the opposite against the rest of the world is in exposition or in performance. And for Dr. Payabi, how can we differentiate the premature deaths related to the exposition of O3 and the that's caused for the exposition to particles and other pollutants, because lately the mix of pollutants, that is to say PM 2.5, O3, NOx, all of that, they act as a whole. So to both of you, if you could please help us with that, and the next questions we see will be asked later on. Go ahead, please. Are you there, Lisa and Dr. Payabi? Hello. I think they are no longer here. Anyway, yeah, I don't think they're here anymore. I do see Lisa Emerson still, yeah, but she's not answering. She's not answering. Anyway, what we can do is we can, well, you can send them the questions. And just the last one for Nathan. You mentioned that ozone is a very complex pollutant more than particles. This is partially true, taking into consideration that particles have a primary origin. However, nowadays, in very large cities such as Mexico City, most of them come from a secondary origin. The chemistry of air sprays is just as complex, if not more, than ozone. This is just a comment. If you have something to retort, or
I'm not an atmospheric chemist. There are some on this, well, hopefully they're in the previous panel, most certainly, who could answer this in much greater detail than me. I don't want to give the impression that particulate matter is simple. It is complex, but there are primary and secondary aerosols, and yeah, infinite complexity to that. However, ozone has other, whether it be you're in a VOC or an N2O limited regime, means that if you don't understand your particular, unlike with PM, if you don't understand your particular meteorology and the mix of the pollutants that are coming, that you're producing, you're self-generating and are traveling transboundary, and you find yourself in one regime and you make the wrong choice on how to mitigate, you could actually see, even though you are seeing emissions go down of meaningful criteria pollutants, you could see concentrations of ozone go up because of the nature of the chemistry of ozone formation. That's not something that happens with PM. And there are many, many examples of that happening all over the world. Mexico City is one of the best examples of how to scientifically and carefully manage this problem. Seoul, Korea is sort of on the other end of that pole in terms of examples. They've very recently seen ozone concentrations go up because they made the wrong choice on which sets of pollutants to address. So that's why I say that it's more complex than PM. Just from a management standpoint.
Agradezco mucho. Yo sé que Lisa y Pabayi están aquí.
Okay, thank you very much. I know Lisa and Dr. Pabayi are here, but I think we are way behind. So I apologize to both of you. Let us move on to the next section. Ramiro, please. Thank you to our three speakers for your presentations and your comments. See you. Thank you to Dr. Telma Castro, researcher on the UNAM Research Center for the Atmosphere.